So thanks everyone for joining this call. It's the first of 4 sessions. So every year we do kind of a roadmap input process where we solicit the community for suggestions, ideas about how to evolve the ONNX standard. You know, ONNX is a living project. It has to kind of evolve and change, make sure it's meeting everyone's needs in order to continue being useful and successful. So we put out the form a couple weeks back. A number of people submitted some great ideas and proposals. And so these sessions are basically for those submitters to share more details about their idea and an opportunity to kind of discuss with the folks on the call a little bit as well. And then eventually these ideas will be taken up by some of the SIGs who actually do the work, with the contributors in the community and get those changes implemented. So with that kind of introduction, I'll turn it over to Saurabh, who's going to kind of MC the different presenters that we have today.
Absolutely. Thank you so much, Prashant. I think in the interest of time, I'll call William and Delaney, who has a proposal around additional Beam search support and dot product attention out. Our goal is that we should be able to cover the presentation in less than 8 minutes, and then which would leave us around 5 or so minutes for any Q&A and anybody attending who can get more clarity on its usage and what are we trying to achieve with it. Does that sound good? Is William on the bridge?
To start off, the first topic I wanted to talk about was some of the issues we are seeing with the FP16 converter. The ONNX FP16 converter specifically. We are seeing in some cases that the converter generates invalid models. Invalid models meaning models that are tagged by the ONNX model checker as invalid. And just looking a little deeper into the issue, I think it comes from the default block list that the converter has, where some of the operators are automatically skipped during the conversion. And this also does not stipulate a strict topological order for the graph. And because of the order being changed, the converter, the checker stipulates this order and enforces to check for the topological order. And because of that, the checker says that the model is invalid. And even when the model is invalid, in some cases, ONNX runtime is able to ingest this model, but in some cases it's not. So because of this usability of the model checker is a little difficult, and it would be great if we can get either relax the model checker requirements because the other parts of the model checker are important, or we make sure that the topological order is maintained for the FP16 converter. So do we want to stop for questions in between or keep going for all the 3?
Yeah, no, continue going and we can have questions in the very end.
Okay, great. And the second part is around the bucketization operator. So we have a lack of support for the ONNX on ONNX side for torch.bucketize. We see this being widely used in GNNs for a pre-processing step where continuous features are discretized using bucketization. And there are quite a few models, including graph attention networks, that widely use this operator, and export of this operator blocks a lot of models on the GNN side. And introducing support for this operator would be like a great addition and would improve usability for GNNs. I just added more details on the slides on what the operator does and where it's being used. I can share more models as well if that would help. I have a list of models that are being blocked because specific message passing layers are using bucketization widely. So that was the second part. And the third part was around custom ONNX function registration with exporters. I've had this discussion with some folks on the call as well. I've spoken about this to Aaron, where when we have new operators that are being introduced by .script, getting support on ONNX has a long lead time. Just with the release cadences and getting them included, there's a longer lead time. And if we have, and ONNX functions have been really helpful for us to build custom functions with existing ONNX operators. That has been really helpful, and it would be great if we can, build custom functions and register that with exporters like Torch ONNX exporter. So it, kind of in the short term unblocks users for exporting PyTorch models to ONNX. That would be a great addition. Those are the three topics that I had. Open for questions.
Great. Can you go through the first one? So I had.
Yep.
So when the checker is failing, is it primarily in the debug that you find that there were issues in how the model was generated, or was it just a checker issue, or it encountered something that was defined in the model?
Yeah, so the model by itself, when it's generated, it passes the checker. But once we go through the FP16 converter, after the conversion, the checker fails.
Okay.
Yeah, and this can be observed in models that are broadly available, and we know that they work. And once we go through the downsampling and we go to FP16 through the ONNX checker, after that, once we go through the FP16 conversion, then the checker will fail for the same converted model.
So, the fix seems to be that the converter should do the topological sort before exporting it.
Yes, that would be great. If you want to enforce the topological order, then having the converter also enforce do the topological sort before saving the model, that would also fix the issue.
Any other questions on the bridge on this topic? Let's go to the next one, Rama.
Yep.
So here, I guess, I think, a PR, proposal for adding the ops, I guess, would be welcome. And if it can be defined as a function, that would be even better. I don't fully know this. Whether it can be defined as a function, or is this something that can be defined as a function using other primitive ops?
I'm still taking a look at that. I'm trying to decompose this into existing ops. I'll be happy to make a more detailed proposal for an op. Either way, either design a function or even an individual op. But I agree, we'll stick with function as much as possible, unless absolutely needed.
Right.
Good. You can take the next one.
Yep.
Just quick comment about this one, the bucketizer.
Yep.
There is a way to do it with a tree. So I did that. I did discretize a real feature into integers using a tree. Oh,
okay. So would that help? Using the tree for doing it through functions? Is that the suggestion?
I guess that's my suggestion. Yes.
So is that using an ONNX YAML operator as opposed to this ONNX domain?
Yes.
Okay.
Okay. Yeah, sounds good. I'll take a look at that as well. I'll reach out to you offline as well.
Okay.
Thanks. All right. If nothing on this, move on to the next one.
So for this, we actually do support in the PyTorch exporter being able to register an ONNX script function to be exported as a custom op. It's something we added in PyTorch, after PyTorch 1.1.3. So it's the documentation is basically just on master right now, but as PyTorch 2 releases, that should be more readily available. I can point you to the link on that as well. And we're also taking the custom op experience into account for our new FX Dynamo based exporter for ONNX as well.
Okay. Awesome. Yeah, I think a pointer to the documentation would definitely help. This would unblock us in many places, and yeah, this is definitely welcome. Thanks a lot.
Yeah, I'll drop the link just a second.
Awesome.
I think that being said, if you find any gaps or if it's if any improvements, we're wildly open to feedback on this as well.
Absolutely, yeah. We'll start using it, probably right away, and I'll reach out to you for any feedback.
Great.
Awesome. That's kind of all I had. I think I do have a few action items on my end that I'll follow up on. If there are any other questions as well, feel free to reach out to me. I'm available on Slack.
Great. Thank you so much for your contribution, Krishna. I think we have representatives from the operators tech here, and they should be able to follow up with you and get your proposal and outcome.
Okay. Sounds good. Thanks a lot.
So much. Thank you for your help. So the next proposal that we have on the roster is from ONNXRoadmap2023 around multi-thread attention operation on ONNX.
Hello, can you hear me?
Yes. We can hear you loud and clear.
I have a presentation.
You're already a co-host, so you can share your screen.
Okay. Can you see it now?
Yes.
Okay, cool. So, hi everyone. Thank you for everything that you do for ONNX. First of all, it's really an amazing tool, this one. And what I'm trying to present now is, try to pitch the insertion of a new operation on ONNX for the multi-head attention operation. And just for everyone, sure that you already know, but just for everyone to be on the same side, what it is, multi-head attention is the key component of NLP model. And NLP model are what actually natural language process model and basically all of them implement some variation of the transformer architecture that was published in 2017. And multi-head attention, and I call it MHA just as a short, to short it, is just a core block of all these transformer architecture. Is the same block, almost replicated with some like variation, replicated multiple times in the same network. And in general, they are a block with many. It's very modular design. And from my point of view, we are looking from as a consumer on the next model to how I'm working in Intel in a hardware accelerator, and our problem is how to efficiently serialize and execute this model on hardware accelerated, particularly in the GPU, if you know what it is. The problem that we face, and I think there's a slight common considering the amount of requests that are similar to mine in this proposal, is that ONNX doesn't have a multi-head attention operator. And so we are kind of forced to do pattern matching to reconstruct multi-head attention for East Coast statement. And it's quite actually really challenging, because if you look at the models that are around, there are a lot of very semantically equivalent ways to serialize multi-head attention. I think I've seen 20 of them. I can send you a slide where we list all of them. And from compiler point of view, for the backend, right, it takes a model and then serializes it. It's kind of a daunting problem, and I'm sure that is something that is shared across all of people that are trying to work with this. And on the other hand, this is a critical component. On the other hand, this is such a critical component that is actually, there's a lot of value in investing it for performance point of view, just to optimize it. Because as I said, it's same component, replicated n times. So every marginal improvement on that is something that will compound on the entire network execution. It's something that there's a lot of gain. There's a lot of return of investment on a highly optimized multi-head attention implementation. And look at what other frames have. We have seen that there are a lot of multi-head attention implementation already implementing PyTorch, Keras, and Paddle as in Atomic Op. That if you look at, for example, one PyTorch implementation that has directly the model, the multi-head attention as part of the model, and even if of course can be implemented as atomic operation, right? There's so much value in having this flag as a big big model, as a big, even if you can use that as a set of layers, there's really a lot of value to have that as a single atomic operation for the backend to that then analyze it, serialize, also for user that can then optimize it. And this is the trend that we see in the industry is that Stratis has more transformative block as part of the native offset, both in those three frameworks. I just try to resume the benefit that I think having this multi-head attention as part of ONNX will bring to the entire ecosystem to the user of ONNX. And first is that this will first simplify ONNX model. Just multi-head attention is a massive layer. Right? In general, it can be, depending on the number of heads, it can be implemented with a lot of layer. And usually when we try to debug model and visualize kind of a mess in general, because it's not a fault, right? It's not anyone's fault. It's just the nature of the model itself. Also, and having all the layer coalesce into one makes the model simpler to manage, debug, and visualize. And that's I think very marginal benefit, but it's a quality of life improvement. The second, I think, is increased popularity of those multi-head attention layer that will exploding over the last month because of ChatGPT and all these siblings, I would say. And it's making operator like that, ONNX will make it easier for developers to take advantage of those NLP models. As another point I would bring is standardization, just because standardized multi-head attention enable a more efficient mapping into the hardware accelerator. Actually, the key motivator for me, I would say, and this will lead customer to have access to efficient performance implementation across multiple hardware clusters. And next, it's kind of the same, is improved performance, right? As standardized, and as this is a key component of those large language models, having a dedicated high performance implementation of multi-head will have a very high return of investment. And as again, it's really by the fact that there are multiple multi-head attention implementation that are depending on how they are semantically implemented, right? Even they are syntactically implemented, they have the same meaning at the end of the day. They may have dramatic difference. Imagine I see implementation where the first, the key head and value have slice layer and all the heads are exploded. The FC implementation with 3D convolution. And there are a lot of ways to implement that. And having a single, let's say, layer with all the parameters will help ensure that models are compatible across a wider range of hardware, and their performance are consistent. And yes, I think it's an overall quality of life that has a big return of investment from customer and hardware vendor point of view. So I don't have anything else. And thanks for the attention. And please ask your questions if you have it.
So yeah, it sounds like a good idea to add. As always, I guess I assume this is something that can be defined as a function in terms of other primitive ops, and so
absolutely.
And
it's actually how now is implemented. Is is a function. It can be implemented as primitive.
Yeah, so adding it as a function of ONNX would very much make sense. I
think I second that as well, because the way I see it is the ONNX offset is moving away from more complex atomic ops to having smaller operations defined with which we can build larger ops as needed. Kind of the comparison between the CISC and the RISC instruction sets. But even in terms of performance, as much as we compose multi-headed attention with smaller operators, through operator fusions and optimizations in the back end for recognizing patterns, can we achieve the same performance without having one big op as multi-headed attention?
So the thing is if there is just a single way, right, to serialize, the multi-head attention can be implemented using multiple atomic operation. Yes, right. The way you can implement it is very high. That's the point. Right. So the way you can have, let's say, multi-head attention with 3 convolution and 2 dot product, or you can have with a bunch of slice layer. Mm-hmm. And there's a lot of ways to implement multi-head attention in the same completely equivalent, functionally equivalent model. But go ahead.
Yeah, but I guess I was just about to say the idea behind function ops in ONNX Impact is to enable both these scenarios, right? That you do have a high-level representation of an invocation of this as a single node, but we also have the potential to inline expand it into a subgraph if a backend doesn't have any explicit support for this op, right? So yeah, having it as a function op should enable both of the requirements to be met.
Yeah, the advantage, to having from hardware vendor point of view, the advantage of having, I'm speaking because I'm facing it every day, right? So the advantage of having, let's say, a black box that says this is a multi-head attention compared to the fact that we have a bunch of operation, right? Is that is way more efficient than from the backend compiler to map that into hardware. We can really afford to fine tune the model itself, the kernel itself to have very high performance kernel. And the downside, if you have that only execute multi-head attention, and the downside is that if you have atomic operation, you kind of execute one after the other, and you can do fusion, but you have to look at this massive graph that is 30, 40 nodes, and then you need to coalesce into one, and it's not trivial at all, because of this small permutation that can happen in the data.
Absolutely. So I have one question around this. Do the converters and exporters have plans to support a function and such a function for multi-headed attention?
Sorry, I have some problem. I think, can you speak a little bit louder?
My question was, do the exporters, let's say a PyTorch exporter or any of the converters that we have, do they plan to support functions and multi-headed attention?
Yeah, so now the PyTorch exporter, I've used that in particular to move from PyTorch to ONNX. It will expand it into ONNX atomic operation, and then just serialize that for the ONNX model.
So if the exporter from PyTorch were to support MHA as a function, then your problem would be solved, right? Then you don't need an operator.
I don't know how, honestly, I'm not super familiar how ONNX work in the details and how the exporter works.
Okay.
But the idea is to have, let's say, the idea is to have, I have these 20 layers, right, that, actually represent a multi-head attention node that I can group together or inline or coalesce in some way. That can, we can say, okay, this is the black box. That is a multi-head attention.
Absolutely. I think that there is a little bit more conversation to be had here. Rama, what is your guidance on this one?
My feeling is, adding it as a function of should be, sounds reasonable to me. It is an important up clearly. I mean, it's widely used, and if it can be defined as a function, there is really no objections. No, I mean, to adding it as to the ONNX standard. So, I mean, it seems to me the first step would be to try to come up with a function definition for this. And I mean, if somebody wants to experiment, for example, you could probably define it as a function in ONNX script, and once a function definition is available, it should be straightforward to add it to the ONNX standard.
Awesome. So, Lisandro, is that something you can follow up and continue working with the SIG on this front? By SIG, I mean the operator SIG. Okay. Awesome.
Yeah,
Any other closing? Great. Thank you so much for your contribution. This is a very important topic. I think all of us would resonate with the statement that you made earlier. So thank you for bringing it to the ONNX ecosystem too. Any other closing statements or any other input from anybody around the multi-headed attention off? Okay. If there is nothing else, I'm going to make another call for the other remaining two topics on the roster. Is William here around the beam search proposal, or is Wei Wen here for the off-BCN v2 proposal?
Yeah, we got confirmation offline that they're not able to make it today. So I think we'll reschedule them for another time.
Okay. If there's no other topic, I think we've more or less covered the agenda today. I'll hand it over to Prashant if there are any other closing statements to make. Otherwise, thank you everyone for your help.
Okay, yeah, we'll end early. Thank you everyone, especially to the presenters who took the time to put together their proposals and make the slides and come here and present that. I think we've identified next steps for all of it. So please follow up on that, especially with the operator SIG. So figure out when we can get those things implemented. All right, so we'll have another session next week with a number of other topics. And yeah, thank you all for joining.
Thank you very much. Have a nice day.
Thank you.